This is 7.3, number 4, right here. So we have 4 over 3 minus 2 over 1 minus 3 over 8. And oh, so you didn't say 4, you said 24? Yeah. Okay, let's just do this one quick because I wrote it down. What should I multiply by? Yeah, multiply by 24. Oh, you said multiply by 24. I understand now. Got it. So if you multiply by 24, you end up with what exactly? Well, 4/3 of 24. 32 minus 48. Yep. 24 minus 9. Yep. What's 32 minus 48? Negative over what? And you're done. Good. You did it right. Okay, kids. Other questions? 12 and 18. What's the least common multiple of the two? 6 is too small. We need. Oh, you said 36? Oh, I thought you said 6. Yeah, it is. It's 36. So what should we multiply this one by? 3 over 3. And what do we multiply this one by? Kids, we're trying to find the least common multiple of 12 and 18. So this is going to be 2 over 2. So we're not done yet because we have x to the 5th in one side and x to the 4th in the other denominator. Sorry, denominators. So what do we need to multiply by to get a... We have x to the 5th already here, but we need x over x. Oh, and then it's y to the 5th here. Y to the 3rd over. So what do we end up with? 15y to the 3rd, right? Plus 10x all over what? All over what?
12.
Nope. 36x to the 5th, y to the 5th. Correct. Because the least common denominator was what? What was the least common denominator? 36, x to the 5th, y to the 5th. We needed to make this in both fractions. So this right here is just a complicated form of 1. And this right here is just a complicated form of 1. So have we changed anything by multiplying by 1? No. Can you simplify anything there? No. Stop there. There's nothing to simplify. There's nothing to simplify. You can't simplify. You can't simplify. There's nothing to simplify there. Stop. You are done. You could go and do that. That's not going to change the validity of the answer. I would be totally okay with this. You could do this, make it 3y cubed plus 2x all over the same thing. I would have still given you full credit on the other one, Summer. But yes, you could take out a 5 on the top. Yes. Nick. 5 on 7.3. So 7.3, number 5. I got it right here. It's okay. So it's 12 over x minus 1 all over 6 over x. Is there anything you can do to simplify either the numerator or denominator fractions? No. So what could you do at this point? What does it equal, Milo? Dividing by a fraction is the same thing as multiplying by the reciprocal. So we're multiplying by what? Correct. Now there's one thing that cancels. Can someone tell me? Raise your hand. I will call it. What cancels, Milo? Yeah, so you end up with 2x over. Done. That's it. Great. That is the quickest way right there. Good job. Thing as we had before. So what do I do on this one, Nick? Dividing by a fraction is the same thing as multiplying by the... So tell me what it should be. 1 minus r over 4r. Nick, stop writing. I know. Stop writing. Look at the board. Tell me what I should do, and you have these notes automatically. Times what?
Times 8 over r.
8r over?
1 plus r.
Correct. So there's a couple things that cancel. What's one thing that cancels?
8r and the 4r.
Well, that's, okay, 2 together. So what does it become? This goes away, and this becomes what on top? No, the r's cancel completely. So you end up with 2 times 1 minus r over 1 plus r. Okay, does anybody have a different one in a different type, maybe? Or something? The other way would be multiply the top. So if you had this right here, if you had this, and you wanted to do it the other way, you could multiply by 8r over 8r. And what's going to happen there? That will cancel with that one, becoming 2. So it becomes 2 times 1 minus r. And then this cancels there all over what? It's the same exact thing. Same method, same level of work, really. Same complexity. Okay, yep.
When you're doing this,
yep.
You want to like simplify
expression.
equation has an equal sign.
Yeah, exactly. An equation has an equal sign. So what we've done so far is simplify rational functions. What we're going to add in is use what we know about simplifying to extend to solving equations, finding answers to equations. answers to equations. Before we solve, though, we're going to find the domain of the equation, the domain. And to find the domain, remember what we do? We start with all real numbers, and we take away the numbers that you can't plug in. The numbers that you can't plug in. Looking at this equation right here, could someone tell me off the top of their head, what's the domain of this one? It's going to be x such that x can't equal what? You can plug in 2. Can someone give me a number you can't plug in? Yeah, Hannah. What? Yeah, you can't plug in 0. Why can't you plug in 0, Hannah? Yeah, your denominator can't be 0. It's the only number x can't be. So the domain would be x such that x can't be 0. What about this one right here? Anybody want to take a stab at this? X such that x can't be. Someone raise their hand and tell me one number. Someone new. Someone new. Liv. Can't be 3, and there's another number it can't be. Liv again.
0.
Nope, it can be 0. You can be 0. Definitely be 0. Harry. Give me -3. You got that from 2 places, right? You got that from here because x can't be 3, and here because x can't be -3. You actually got it from here as well. Exactly, because both of them are here, right? The reason you do that is because when you solve these when you solve these equations, you're going to get potential answers. 7, I'm just making some stuff up. Let's say you solve one of these. Let's say you solve this one, and your answers, can you have more than one answer? Sure. Let's say the answers were 7, 8, and 3. Is 3 allowed to be an answer? No. So you take it away, and your answers are only 7 and 8, the other 2 ways. Those aren't the answers to that one. The reason you check the domain is sometimes you get false answers. You do all the proper math, but you get a false answer, so you have to take it away. So the first thing you do is find the domain. This should not take a long time. It should not take a long time. So let's now work at solving one of these using methods we already know. To add or subtract fractions, what do you need? So we actually get to skip around a little bit and do something faster. We're first going to find the least common denominator of all of the represented fractions. Can someone tell me what the least common denominator on that one is? Alex. 2x. It is 2x. So step 1 is going to be find the domain. Step 2 is going to be find the LCD. And then step 3 is multiply by the LCD. Side note, everybody, here's a side note. If A equals B, is it true that 5A equals 5B? Yeah. Remember what that rule is called? It's called the something rule of algebra. It's called the golden rule of algebra. What you do to one side of an equation, you have to do to the other side. That's generally very true. So the idea is, if we wanted to, could we multiply both sides by pi if we wanted to? Is that going to help us in any way? No. Not really, but could we, and will it remain true, the statement, the equation? Sure. How about we multiply instead both sides by 2x? Is that allowed? If we multiply both sides by 2x, we're multiplying this side by 2x, and we're multiplying the other side by 2x. If we're going to multiply here, what happens on the right-hand side? What happens right here? What cancels on the right-hand side? Milo, what happens? Exactly, this goes away, and what are you left with? Oh, that makes you feel a little happier, right? On the other side, what do you have to do here? What is this called? We have to distribute. So that's going to be 2x times 2 over x minus 2x times 3 over 2. Oh, what's nice here? What cancels here, Milo? Just the x's, and you're left with 2 times 2. 2 times 2 is 4, because it's over 1, remember? What cancels on this one right here? What cancels right there? Milo, finish it. 2, so what are you left with? So minus 3x equals 7. Is that a bit simpler than what we started with? Sure, so you get negative 3x is equal to negative 3. So what does x equal? What's x equal?
Well, isn't it just regular 3, not negative 3?
Oh, it is just 3. Thank you. I can't do subtraction. So x is going to be equal to what? Negative 1. So you're done. So that last thing was we multiplied. We could say simplify. What's a great, so we multiply, simplify, and solve. I'm writing out too many steps here. We'll simplify this again. But after you solve, what's a great thing to do at the end? Check. The big important ones are, kids, that you need to remember: domain, LCD, and solve. Those are the big 3. What are you going to do with the LCD? Multiply everything by the LCD. So let's do another one here. It's a little bit more fun. At least I think so. Let's go back to this one right here. And let's say we wanted to simplify this one right here. What was that first step? Find the domain. So what's the domain? Or you figured out the domain of this one. What is it?
-3.
The domain is not -3 and 3. It's x such that x can't be -3 and 3. That's the opposite. You have to say the whole thing. Whole thing. What was that second step? Find the LCD. Can someone tell me what the LCD is going to be? Nope. Oh, actually you said x squared minus 9? That's true. Say it better. Say it factored.
X plus 3 minus 3.
Yeah, exactly. Say it like that. Say it like that. That's easier. Why is that better to say like that? Well, we now need to multiply everything by the LCD. It's easier to see the simplification when it's written out like that.
Yeah.
So if we multiply this whole thing by the LCD, you end up with 2 over x minus 3. We're going to pause for 1 second. A lot of things that cancel.
Yeah.
Well, first of all, that cancels with that, right? Oh, the x plus 3's cancel in the middle. And then what cancels here? The x minus 3's cancel. So Mar, what are you left with?
2 over
2 times.
3
Minus equals what? Is that a lot easier than what we started with? Yeah, so what's the one word for what we need to do next, Nick? Distribute. So you get 2x plus 6 minus 3x plus 9 equals 12. How many x's do we have? 2 of them and -3 of them. So we have negative x plus 15 is 12. So negative x is -3. So what does x equal? Oh, wait a minute. So that's a solution, right? But what did we say the domain was? Look in the upper right. What's the domain?
X is
X such that x can't be 3 or -3, right? So we solved it, right? But we can't use this one. So what's the answer to this? No solution. If you had said the answer is 3, can you plug in 3 into this equation? No. So there's no solution to this one. It's kind of cool. Okay, sit down, kids. In finding the domain, we better do what first? You just said it? Factor. So do that for me. Fully factor all of those. Fully factor all of those for me. Factor the first one. It's going to be 3 over what? P plus 2 times P minus 1. Exactly. And what's the next one factor into? P times P minus 1. That's the difference of squares. Equals 7 over 2 times what? Exactly. So so let's find the domain here. We know from this one, P can't be -2 or 1. On this one, P can't be what? -1 or 1. And on this one, P can't be -2 or -1, right? So what's the domain going to be? X such that x can't be equal to what? -2, -1, or 1. You can still plug in 2. Okay, so after you've done that, you need to find the LCD. Can anybody tell me what the LCD is going to be? Someone tell me one thing that has to be in the LCD. Hannah.
2 times P squared.
Hold on, 2. So 2 is in there. What else is in there? In factored form again. Do it in factored form. 2. Yes, P plus 2 times P plus 1. There's your common denominator. Why? You have a 2 right here, so that has to be part of it, right? You have a P plus 2 in 2 of them, so that has to be a part of it. And then what else? There's a P minus 1 and a P plus 1. Oh, look at that, P minus 1. So what else do we have to have in the denominator? P minus 1. So it's a bigger denominator, but what happens after we multiply by this least common denominator? A lot of things cancel, right? So it might get worse before it gets better. You hear that? You hear that sometimes, huh? So if we multiply this out, what do you end up with? We're going to take this and multiply it right here. Is it okay if I don't write the whole thing out again? Is that okay? What's going to cancel? You're going to be left with 3 times what? The P plus 2 cancels, and so does the P minus 1. So what are you left with? 2 times P plus 1, right? Correct?
Yeah.
Minus 1 times, what cancels now? P plus 1 and P minus 1. So you're left with 2 times P plus 2 equals, oh, we still have to get the, oh, we got the 2 in there, good. On the last one, what's left here? 7 times what? P minus 1, right? Does everybody see how we got from here to here? Okay, so we're going to talk about that. What did you get for P?
3.
Who got an answer? Who got 3? Raise your hand if you got 3. Now let's look at the domain. Is 3 in the domain? Yes, 3 is in the domain. Yes, it is. 3 is not one of the numbers that can't be in it, so 3 is in the domain. So what's the answer? Yay! Now, could you check it at this point? You could. So let's keep practicing. See up there. So first of all, you did the domain stuff first, right? Shh. Girls? Girls. Do you know what this is? This is a grip. Find one. Okay, domain. Oh, snap! Okay, so it's x such that x doesn't equal what?
0.
0 or negative a third, right? So then you did this out, and you found out that the LCD on this thing was equal to x times 3x plus 1. And when you multiplied, you end up with 2 times x equals 1 times 3x plus 1 minus 6x times x. And some of you were a little dismayed when you got this because you were like, man, I don't like this. But is it really that bad?
No.
No, you get 6x squared minus x minus 1 is equal to 0. Does that factor? The key is it has to equal 0. If you're solving by factoring, it better equal 0 because you need that 0 product property. So does it factor? Yeah, what does it factor into, Mar?
3x plus 1.
Plus 1 and what?
2x minus 1.
Awesome. So that tells you that 3x plus 1 is equal to 0, or what? 2x minus 1 is equal to 0. So you have 3x is equal to negative 1, so x is equal to negative a third, or 2x minus 1 equals 0, which tells you that 2x is equal to 1. So what does x equal? Oh, so then you're not quite done yet, because this right here is not in the domain. So what's the only answer? This is your only answer right there. That's great. That's great. Yeah.